Today, we're going to dive into a really fascinating piece of AI research. It's called DINOv3, and it's a huge step towards an AI that can basically teach itself to see the world without us having to hold its hand every step of the way.
But this whole thing brings up a really big question, one that's been at the very heart of computer science forever. How in the world do you teach a machine, a bunch of code, to see and actually understand a picture the way you and I do?
Well, the way we used to do it had this massive problem. The whole field calls it the annotation bottleneck.
You see, for years, the only real way to get an AI to learn was just brute force. You'd get millions and millions of images, and then you'd have teams of people, actual humans, go through and label every single thing. Okay, that's a cat. That's a building. This little smudge here, that's a specific type of tumor on a medical scan. It is unbelievably slow, it costs a fortune, and it's a fundamental limit on how much an AI can possibly learn.
So, because of this huge bottleneck, researchers started chasing this dream really, a much more powerful idea, the self-supervised dream. And the core idea here is something called self-supervised learning. The goal is to get an AI that could learn just by observing, by just looking at billions of raw, unlabeled photos from all over the internet. Kind of like how a toddler learns, right? It just watches everything, and eventually it starts to figure out the patterns and the rules of the visual world all on its own. And when you put them side by side, you really see why this is such a game changer. The old way is totally capped by how many hours humans can work. The new way, it's scalable. It basically turns the entire internet into one giant textbook for the AI, letting it learn from way more data than we could ever hope to label by hand. And that is where DINOv3 comes into the picture. It makes some incredible progress toward this dream, and it pulls it off by focusing on 3 really key innovations.
And look, this isn't some kind of black magic. The research paper for DINOv3 shows that its success comes from combining a few simple but just incredibly effective strategies.
Okay, so let's break these down. First, they figured out how to scale things up the smart way. Second, they came up with a new technique to sort of anchor the features the AI learns so they don't get messy. And third, they built in this amazing ability for the model to adapt on the fly, even after its main training is finished.
All right, first up, scaling up smartly. This is so much more than just throwing a bigger model at a bigger pile of data. Nope. The DINOv3 team was super careful about cleaning and preparing their dataset, and they designed the AI's architecture so that as it got bigger, it also got way more efficient at learning.
Next is this thing called gram anchoring, and this is a really cool solution to a super common problem. See, when these big AI models train for a long time, their internal understanding of an image, their sort of feature map, can get all fuzzy and distorted. Gram anchoring is like a mental anchor for the AI, holding those key visual patterns steady and keeping its internal map of the world crisp and clear.
And finally, we have these post hoc strategies. Think of this as the secret sauce that makes the model so flexible. After all the heavy, expensive training is done, they apply these clever little tricks that let the final model adapt to different image sizes or run on different types of hardware and even connect what it sees to what it reads in text.
So, these 3 innovations sound really great in theory, right? But what about the results? Well, this is where things get seriously impressive. DINOv3 has set a completely new state of the art. I actually want to read this quote straight from the paper because it's just so powerful. They say DINOv3, quote, outperforms the specialized state-of-the-art across a broad range of settings without fine-tuning. Now that little part, without fine-tuning, is absolutely crucial. It means this general-purpose model, right out of the box, is better than other models that were painstakingly trained for just one specific job.
And when you look at the results, it's just plain striking. On one side, you've got these models that are hyper-specialized for one thing. And then you have DINO3, which just performs better. Across the board. It's a generalist that literally beats the specialists at their own game.
So what you end up with is what's known as a foundation model. It's a single, super powerful, and really versatile base that can now be used for an incredible number of different visual tasks, whether that's analyzing aerial photography or finding patterns in medical images.
Okay, so a new AI model is the best in its class. Big deal, right? Well, actually, this is a huge deal. Why should you care about this?
Well, for starters, it means we have one model that can be applied to countless different problems. It means AI development is about to get a whole lot faster now that we're starting to break free from that annotation bottleneck. It truly unlocks the entire internet as a learning resource. And what that means for all of us is more powerful, more accessible AI tools for everyone, from scientists and engineers to creators.
And all of this leaves us with one last, Really fascinating question to chew on. For so long, we've been teaching AI to see the world through our eyes with our labels. But now that it can teach itself, using a scale of data that we can't even comprehend, what's it going to notice that we can't?